Bismillah ar-Rahman ar-Rahim. Alhamdulillah. Wassalatu wassalamu ala Rasulillah. This is section 11.2 and it's about series. And we will talk about infinite series. As we talked in section 11.1 about infinite sequences. Uh, Infinite sequences where we write the sequence like this, n from 1 to infinity. And we say that an infinite sequence is just list of numbers. So A1, the first term, the second term, the third term. It continues to the nth term, and it continues also. After an, I have an plus 1, and so on. This is an infinite sequence. This is what we studied in 11.1. Now, if we add the terms of the infinite sequence, so if we add a1 plus a2 plus a3 plus, then this infinite sum is called an infinite series or just a series. So when we say series, we mean infinite series. And of course, we can write this sum using the summation notation. So it is summation an from 1 to infinity. If n is 1, you will have a1 plus a2 plus. So the infinite series is the sum of the terms of an infinite sequence. That's it. Now, the question, how to find this sum? Is it possible that this sum converges to a number? In fact, it could be it could it could be convergent and it could be divergent, the series. It would be convergent if this infinite sum equals to a number. It would be divergent if the infinite sum is equal to infinity, goes to infinity, increases without bound. So how to define this? Well, I can define this uh, like the way we defined the definite, the improper integral. If you remember in section 7.8, I believe, we had improper integrals like this from 1 to infinity, f of x dx. And how did we define this? We said it is the limit. We replaced infinity with t and said it is equal to the limit of this when t approaches infinity. So this is an infinite area. This integral represents an infinite area. And to evaluate the infinite area, we evaluate a finite area. This is finite area, but in terms of t, and then we take t to infinity. So here we have summation of an, where n is from 1 to infinity. This is the series. So we can write it limit ai, I from 1 to n, and we take n to infinity. So this is the same way we deal with the improper integral. We also deal with the infinite series. So we find this sum. And what is this? This is the sum of the first n terms of the sequence. So the sum of the first n terms, when we get it, it would be in terms of n. We take n to infinity, we get the summation of the series. So summation ai from I equals 1 to n, this is the sum of the first n terms of the sequence. we will give it a name. We will call it Sn. Okay. We will call it the nth partial sum. And we will call these sums partial sums. So S1, for example, would be A1, the first term of the sequence. S2, the sum of the first two terms of the sequence. S3, the sum of the first three terms, and so on. So Sn is the sum of the first n terms. So this is a sequence. We call it sequence of partial sums. And we can talk about the, the sequence of partial sums. This is the sequence, consists of S1, S2, Sn, and so on. It is an infinite sequence. So this is the sequence of partial sums. This sequence could be convergent or divergent. If it is convergent, if it has a limit, if limit Sn when n goes to infinity is S, this means that when you, what happens when you take Sn, when you find limit of Sn when n goes to infinity? If you take this n to infinity, you reach what? You reach the series. Okay, that's what we said, yes? The series would be the limit of the nth partial sum. So if you find that this partial sum has a limit, this is Sn, by the way. This is Sn. So if limit Sn when n goes to infinity equals S, then the series equals to S. Then the infinite sum equals to S. Then the series converges, is convergent. Okay? Then we call it the sum of the infinite series. So S in this case, which is the limit of the sequence of the partial sums, would be the sum of the infinite series. So this is the series, okay, the infinite series, and Sn is the nth partial sum, and it's defined as the sum of the first n terms. If the sequence Sn converges to S, for example, then the series, the infinite series, is called convergent, and the infinite sum, this infinite sum would be equal to S, where S is a real number. Or you can write the infinite series equals to S. So when you add the infinite series, you find a number. This is uh, similar to what we had in the improper integral. We have an infinite area, and we found that some improper integrals are convergent, and they are convergent when this limit exists equals to a number. The number S is called the sum of the series. If Sn is divergent, the sequence Sn, then the series is divergent. So notice that here in this situation, we have two sequences and series. This sequence is the sequence of the terms of the series, the terms. And the convergence or divergence of this sequence has nothing to do with the convergence or divergence of the series. The convergence or divergence of the series depends not on this sequence, depends on the sequence of the partial sums, this sequence. If this sequence of partial sums converges, then the series converges. And if this sequence diverges, then the series diverges. All right. Now suppose we know Sn. We have Sn, the sum of the first n terms. Sn is given. So when we add the first n terms, we can write it in this way. Can you find out the sum of the infinite series? What is the sum of the infinite series? It is S. It is the limit of Sn. So if you can find the limit of Sn, which is 2n over 3n plus 5, when n goes to infinity, what is this limit? What do we do? Term with highest power, term with highest power, n over n. So the limit is 2 over 3. So what is the sum? The sum of this series from 1 to infinity is equal to 2 over 3. So if you know if we have Sn, we can find its limit and we can determine whether the series is convergent or divergent. And if Sn converges, then we found the sum of the series. Question: calculate the sum of this series whose partial sums are given. So Sn is given. So let us find the limit of Sn when n goes to infinity. Well, 0.8 to the power n, this is in the form r to the power n. And r is less than 1, 0.8 is less than 1. So we have seen in the previous section that the limit of this would be 0 because r is less than 1. So the limit would be 2 minus 3 times 0 equals to 2. So the limit of Sn would be 2. This means that the sum of the series of an from 1 to infinity is equal to 2. Okay, suppose that Sn is not there. And that's usually the case. We don't have Sn. Usually, Sn is not given. So how to find out whether the series is convergent or divergent? Well, for some series, like this series, and they can be changed to what we call telescoping sum. And we can find Sn for this series. So this kind of series, when you have here n times n plus 1 or n times n plus 2 or n minus 1 times n or times n plus 1, you can actually deal with this series and find Sn, the nth partial sum. What is the definition of Sn? It is summation ai from 1 to n, the sum of the first n terms. What is here? If we look to this series, what is this? This is an, isn't it? So what is ai? You replace I, you replace n by I. It would be 1 over I times I plus 1. Now we can write this series, if you remember in section 7.4, when when the denominator is factored and I have a rational function, I can write this a over I plus b over I plus 1, isn't it? Partial fractions. And I can find a easily by replacing I here by 0, forgetting about this I. So if I put I 0, then 0 plus 1, 1, 1 over 1 is 1. So A is 1. And B, I replace I by -1, but canceling this. When I replace I by -1, 1 over -1 would be -1. So B is -1. If you need any help, go back to section 7.4. So I can write this series as summation, not series, the nth partial sum, as A over I. A is 1, so 1 over I, and B is -1, so it would be minus 1 over I plus 1. So I can write this 1 over I times I plus 1 like this. Now this is called telescoping sum. Why? Let us see. Let us find this sum. Okay, let us expand the summation. So replace I by 1. When I replace I by 1, I'll have 1 minus a half. This is when I equals 1 plus. Replace I by 2, the second term. 1 over 2 minus 1 over 2 plus 1, 3. This is when I equals to the second term. What about the third term? When I equals to 3, it would be 1 over 3 minus 1 over 4. And the terms continues. If I ask you what would be the last term, what is the last term of this sum? You say when I equals n. So the last term would be 1 over n when I replace I by n minus 1 over n plus 1. So this would be the last term, and we will get it when we put I equals to n. What is the previous term? Okay, when you put I equals n minus 1, because n minus 1 is before n. So replace I by n minus 1, replace I by n minus 1 plus 1, so it would be n. What would be the previous term when I is replaced by n minus 2? So it would be 1 over n minus 2, and here n minus 2 plus 1, so n minus 1, and so on. There are a lot of terms in between. Now look carefully. Negative half, you can cancel negative half with half, and negative 1 over 3 with 1 over 3. And if you replace I by 4, the first thing here you will have 1 over 4, and you can replace negative 1 over 4 with 1 over 4. So you can in fact cancel. All of these terms would be cancelled except the one here. So this one is not going to be cancelled. Okay, let us look to the last terms. This is negative 1 over n, and this is positive 1 over n, will be cancelled. This is negative 1 over n minus 1, and this is positive 1 over n minus 1. If you use I equals n minus 3, minus 3 plus 1 would be minus 2. So you will have negative 1 over n minus 2 here, and it would be cancelled with this. And all the terms in between will be cancelled, except the last term, which is what? Negative 1 over n plus 1. And that's why they call it telescoping sums. They cancel each others. And at the end, you will have one term from the beginning and one term from the end. So two terms only. You will have here two terms because the difference between n and n plus 1 is 1. If this is 6, this is 7. The difference is 1. Now this is Sn. So you can write Sn. See, we can find Sn. So now you can find the limit of Sn when n goes to infinity. And the limit of Sn would be limit of this, and 1 over infinity is 0. So the limit of Sn is 1. And this means that the series converges to 1. And the sum of the series is 1. So summation n equals 1 to infinity of 1 over n times n plus 1 is 1. This infinite sum equals to 1, and the series is convergent. Okay, so terms cancel in pairs, and we call it telescopic sum. Determine whether the series is convergent or divergent by expressing Sn as a telescopic sum. If it's convergent, find its sum. Here the question is ready. We have two terms already. Okay, it's not written number over n times n plus 2. So the first step is not there. The partial fraction is not there. It is done for us. So I immediately find the terms. Notice that the difference between n and n plus 2 is two numbers. So if n is 2, n plus 2 is 4. So here, for Sn, we will have 4 terms, not 2. 2 from the beginning and 2 from the end. Well, what is the idea? The idea is express Sn. So let us start by finding Sn. What is Sn? Summation of AI from 1 to n. The sum of the first n terms. This is what? This is an. So what is ai? I replace n by I. Okay, from 1 to n. Let us expand Sn. Replace I by 1. 1 over 3 minus 1. Here we replaced I by 1. Replace I by 2. 1 over 4 minus 1 over 2. Here we replaced by 2. Replace I by 3. 3 plus 2 is 5. Here I is replaced by 3. Replace I by 4. Here I is replaced by 4, and so on. Now let us find the last terms. The last term when I is n. So this would be 1 over n, and this would be 1 over n plus 2. This is when I equals n. The previous term would be when I equals n minus 1. So this would be 1 over n minus 1, and this would be n minus 1 plus 2, n plus 1. The previous term when I equals n minus 2. This would be 1 over n minus 2, and this would be n minus 2 plus 2. It would be 1 over n. Replace I by n minus 3. I will have here 1 over n minus 3, and here 1 over n minus 3 plus 2, so n minus 1, and so on. Let us see now the cancellation. 1 over 4 would be cancelled with 1 over 4. 1 over 5. 1 over 3 also is cancelled with 1 over 3. 1 over 5 would be cancelled with the next term here. When we take I5, this would be negative 1 over 5. So 1 over 5 would be cancelled. And then 1 over 6 would be cancelled. So all the terms would be cancelled except negative 1 and negative half. Two terms, because the difference between n plus 2 is 2. And here at the end, you will notice that negative 1 over n, positive 1 over n, they will be cancelled. Negative 1 over n minus 1. Notice that if the first number cancelled, 1 over 3 of the two, then the first number of each will be cancelled. Okay, and then it would be cancelled with what? With this one, the second number here. So these two second numbers will not be cancelled. Here the same, look, negative 1 over n will be cancelled with 1 over n. So I understand immediately that negative 1 over n minus 1 would be cancelled with 1 over n minus 1. And that negative 1 over n minus 2, there will be a term here, 1 over n minus 2, and it would be cancelled with it. And negative 1 over n minus 3 would be cancelled with. What are the two terms that are not cancelled? 1 over n plus 1 and 1 over n plus 2. So Sn, in fact, is negative 1 minus half plus 1 over n plus 1 plus 1 over n plus 2. And now, when I find the limits of Sn, when n goes to infinity, these two will go to 0 because 1 over infinity is 0. And the limit would be negative 1 minus half, which is negative 3 over 2. So the series converges to summation 1 over n plus 2 minus 1 over n would be equal to negative 3 over 2, of course, from 1 to infinity. So this series converges. Also in this question, I have sum of two terms. So it's ready. So what is Sn? Again, summation I from 1 to n of AI. This is An. So what is AI? 1 over square root of I minus 1 over square root of I plus 1. What is the difference between n and n plus 1? 1. So I should find here two terms, Sn. Let us find Sn. Replace I by 1. So I have 1 minus 1 over square root of 1 plus 1, 2. Do it easily and take your time not to make mistakes. When I equals to 2, I'll have 1 over square root of 2 minus 1 over square root of 3. Another term when I equals to 3, 1 over square root of 3, 1 over square root of 4, and so on. The last terms when I equals to n, square root of n plus 1, and here square root of n. This is when I equals to n. When I equals n minus 1, n minus 1 plus 1 is square root of n. And here I have square root of I, which is n minus 1. The last term I'm going to write when I is n minus 2. So I will have 1 over square root of n minus 2 minus square root of n minus 2 plus 1 n minus 1 plus plus plus. Notice that 1 is not cancelled. The first term is not cancelled. The second is cancelled with the first one here. So the second will be cancelled with the first one here. So the second would be cancelled with the first one here. And one is not cancelled. Now look here. Negative, this is not there anywhere. So this term, which is the second, is not cancelled. This one, if you go from the right, let me call this the first from the right. This is the second. So the second one is cancelled with the first one here. So this second one will be cancelled with the first one here. And this second one will be cancelled with the first one here. And as you can see, Sn would be this one minus 1 over square root of n plus 1. And the limit of Sn when n goes to infinity would be 1 because 1 over infinity is 0. So the series converges to 1. Okay, I can say series converges to 1, or I can write the sum as usual. Okay, series. All right. Notice here I have n and n plus 3. This will be somehow long because the difference 4 numbers between n and n plus 3. So I will need 6. Sn would consist of 6 numbers, 6 terms. So let me start from here. Sn is summation ai and I from 1 to n. This is an, so ai would be 3 over I times I plus 3. And notice that this is not written in terms or in the form of addition. So I need to use partial fraction to write 3 over I times I plus 3 equals A over I plus B over I plus 3. So if I is 0, I will get 3 over 3, so A is 1. If I put I negative 3, 3 over negative 3 is negative 1. So I can write this as summation from 1 to n, 1 over I minus 1 over I plus 3. So 3 over this equals to this. Good. So now let me expand Sn. So Sn would be equal to, let me replace I by 1. I'll have 1 minus 1 over 4. Replace I by 2. I'll have 1 over 2 minus 1 over 5. Replace I by 3. I'll have 1 over 3 minus 1 over 6. Replace I by 4. I'll have 1 over 4 minus 1 over 7, and so on. Notice that, let us start cancelling. Okay, 1 not cancelled, 1 over 4. Okay, the second term here is cancelled with this one, with the first term here. This means that the first term here and the first term here will remain without cancelling. And 1 over 5 would be cancelled with 1 over 5 here, the second, and 1 over 6 would be cancelled, and 1 over 7 would be cancelled. And then we will have Sn equals 1 plus half plus 1 over 3. These are the 3 terms from the beginning. Now at the end, okay, when I put I in, I'll have 1 over n minus 1 over n plus 3. When I put I n minus 1, I'll have n minus 1, and here minus 1 plus 3, so plus 2. And when I put I n minus 2, I'll have n minus 2, and minus 2 plus 3 is n plus 1. One more term, when I is n minus 3, n minus 3 plus 3 is just 0. Sorry, is just n, and so on. Let us see the cancellation. What happens? The first term from the right is not cancelled, is it? It is. It would be cancelled. Negative 1 over n plus 3 with 1 over n. No, no. This is a plus, this is minus. Sorry, there is no cancellation. So there is nothing to cancel with 1 over n plus 3. Good, this will remain. Now look to the second term, 1 over n. Oh, it's cancelled with this one. Negative 1 over n plus 1 over n. This means that this first term and this first term will not be cancelled because we started cancelling 1 over n from here. Okay? So the second term always cancelled. So 1 over n minus 1 would be cancelled with the term here. And this one would be cancelled with the term here. So Sn would be, these three will remain. So I have negative 1 over n plus 1, negative 1 over n plus 2, negative 1 over n plus 3. And the limit of Sn when n goes to infinity, okay, all of this would be 0 because infinity in the denominator. So the answer would be 1 plus half plus 1 over 3. And this is 6 over 6, 3 over 6, 2 over 6. So the sum is 11 over 6. So the series converges to 11 over 6. The sum of the series is 11 over 6. Let me take this example and stop after it. So again, this is also a telescoping sum, and it's clear here because there is a minus. And you can see 1 over n, 1 over n plus 1. So let us find Sn and start Sn is summation I from 1 to n, ai, and this is an. So ai would be e to the power 1 over I minus e to the power 1 over I plus 1. Let us start writing the terms of Sn. When I is 1, I have e to the power 1 minus e to the power half. When I is 2, I have 1 over 2 minus 1 over 3. Notice that the difference between n and n plus 1 is 1. So Sn here will consist of 2 terms only. So it's enough to write 2 are enough. I can understand from here that this will be cancelled with this immediately. So this second term will be cancelled with this. And we will left with e here. Okay. Now let us find the last terms. When I is n, so I will have e to the power 1 over n minus e to the power 1 over n plus 1. This is when I equals n. Now when I equals n minus 1, I'll have 1 over n minus 1 and 1 over n minus 1 plus 1 is n. Okay, and you can see that immediately this second term is cancelled. So this second term will be cancelled and so on. And Sn will consist of 2 terms, as we said, because the difference between n and n plus 1 is 1 number. So the first term is e, and the last is e to the power 1 over n plus 1. So this is Sn. So what is the limit of Sn when n goes to infinity? Well, this is e, and n is infinity. 1 over infinity is 0. E to the power 0 is 1. So the series converges to e minus 1. And it is convergent. Thank you very much. I hope you understand this. And the next video will be about geometric series.